All right. Hello, everybody. I'd like to welcome you to our talk about creating vector tiles from OpenStreetMap. It's great to be here. We enjoyed this conference very much. We were here for the first time, and now we hope that we have something interesting for you this afternoon. So, a bit about us. This is Lucas Martinelli, and I'm Manuel Roth. We are both computer science graduates from the University of Applied Science, Rapperswil in Switzerland. And for the past year, we worked on a project called OSM2 Vector Tiles. So, what you will know after this talk. So, we'll talk about what vector tiles are and what are their advantages over traditional raster tiles, like a little bit we heard before, what the purpose of the OSM2 Vector Tiles project is, and how you can use it in your project as well. And in general, how you can turn OpenStreetMap data into vector tiles and what you need to look out for. And especially how you can create your own vector tile set.
And just to add to what we heard before, it's important, the biggest advantage of tiles is that they always cover the same area. And this means we can pre-compute it, we can cache it very easily. And you shouldn't forget that, that's the biggest advantage. And vector tiles are very similar, and I'm very glad Boundless made a great explanation how that works. And vector tiles, it's even better than with raster. We can just create them once for a purpose, like for the purpose of a base map, and everyone can use them and apply their custom styling. So we hope there is no need for you to go through all this work we will show you to create your own map. Use our vector tiles. And really keep that in mind. You only need to create them once and other people can use them. And I really hope that you see more open vector tile layers in the future.
So the goal of the OSM2 Vector Tiles project was to build a place where you can download these vector tiles, like the entire planet. We have over 200 countries and more than 600 cities. To really give you a starting point where you can download these vector tiles and use them. And secondly, the target was to build a workflow based on Docker, which should be very straightforward to go from raw OpenStreetMap data to vector tiles. And third, most important one, we want to empower everyone to create their custom base map. So now I give a little demo of our website. I hope it's over there, yeah. This is our website, it's called osm2vectortiles.org. You can go in it and there is a map section where you can choose between three predefined styles. There is the bright style, the liberty style, and the basic style. And under the map you can see a HTML sheet where you can just copy and you get a full screen map, but which uses the CDN for hosting the vector tiles from us. But what we actually think is the way to go is go to the download section, download the vector tiles and serve them yourself, so you can be independent. So in the download section we provide vector tiles for the whole planet, for many countries, more than 200 and more than 600 cities. And now I'm going to demo how you can do that. So because we are in Bonn, we're searching for Bonn in Germany. We can just copy the link, going to command line, I hope you can see that. Download this mbtiles file, and this mbtiles file is basically just an SQLite DB with all the vector tiles in them. So we downloaded it. And then we can use a tile server. In this case, I use tile server GLite, which will be presented after our talk. We can just give the argument like this, and then we have a tile server on port 8080. And here on the bottom, you get an X-ray viewer, which shows you what's inside these vector tiles. So you get really a basic view. You can hover over certain features, and on the right-hand side, you see the attributes. So you can really just play around, see what's in them, what you can actually style afterwards. Also, if you want to create your own style. But this is really the place to get started with vector tiles. So now back to the presentation. And in the rest of the presentation, we really want to focus how you can create the vector tiles and what you need to look out for.
So creating static vector tiles is not that hard, and I will show you an example how to do that with Mapbox Studio Classic. We are always talking about vector tiles in the Mapbox vector tile specification now. And there are other options as we've seen before. And a very easy way to get started is with the traditional shapefile. So for OpenStreetMap, you can download a shapefile from Metro Extracts. And so we download that and we unzip it. And now we're going to choose the admin boundaries, so the admin shapefile, and we're going to create a new source project in Mapbox Studio. So we're opening it, create a new source project, and we will add a new layer that will reference that shapefile. So we browse it and reference the previously downloaded shapefile, admin, voila, we have it here. We can click on the data and we see the metadata, and we can zoom around, and now we already started with creating our own vector tiles. Now exporting them as MB tiles format is easy. With the graphical user interface, you can just go to export and it will dump a SQLite file for you. So it's not scary, it is easy to do. However, if you do it on a bigger scale, that no longer works, and we don't recommend that you download shapefiles for OpenStreetMap and turn it into vector tiles. We really find that using a database like PostGIS gives you the most power, because you're going to want to integrate other data. OSM is not enough, like natural earth, and you want to generalize, you want to calculate labels, and all the power that PostGIS gives you. So we built our workflow around this, and if you build maps with Mapnik, you will know this stack, and it's essentially the same. You import it with a tool like OSM to PostgreSQL, in POSM, import your other data, and then there's just these encode steps that turns the SQL queries into vector tiles. And that's what you're going to show next.
So now we are going through each. Okay. You wanted to.
So we Dockerized this entire process, so it's very easy for you to use. And we use Docker Compose to orchestrate your containers. So you don't need to install anything. You just need Docker and Docker run, and then you can do this entire thing yourself. You put in an OSM PBF file, and in the end you get the vector tiles, MB tiles.
So now we talk a little bit about each step. So first is importing the OpenStreetMap data into PostGIS. There are two options, basically, OSM to PostgreSQL and in POSM 3. We decided to choose in POSM 3 because it's very fast and it has this nice configuration where you can define which OpenStreetMap tags get imported into which database table. So on the right-hand side, we can see an example of this configuration. There is defined a database table called buildings, which all OpenStreetMap tags with the key building get imported. We found that it's very important to only import the OpenStreetMap data which we actually want inside the vector tiles and leave out all the rest. So this was very a convenient way to do this. What also was very helpful for us or important is pre-process as much as you can. Like do heavy stuff like generalization, heavy functions like calculating centroids for the labels or splitting large polygons. Do that before so that you don't have to calculate these things at the time where you are generating the vector tiles. So this part keeps very fast. So here's the demo of how the workflow works. There is a Docker Compose command which starts the Postgres database. Now it's started. We download a PBF. In this case, it's Switzerland. It's Zurich. It's a city in Switzerland. And in the next step, we are going to import this OpenStreetMap extract. So we run the command import OSM, and it will read this file, import it within POSM 3, and after this, it will do generalization, splitting big polygons, calculating the centroids for the label placement. So we did all this work for you, basically. So now everything is in the database. All the data is there we want to have in the vector tiles afterwards. Now we are ready to create the vector tiles. But before we can do that, we actually need to define, how should this data be aligned inside the vector tiles. For this, we need to know a little bit more what actually is inside a vector tile. So a single vector tile consists of a named set of layers. This could be a building layer, a road layer, a water layer, whatever you want. And each of these layers contain the geometric features and their metadata. So a description is used to define all of this layer and where to get this data from. In our case, this is an SQL query which queries our Postgres database, but this could also be a shapefile or a GeoJSON file. So here we can see in an example on the right-hand side, again, we have this description of the layer for the building layer and the corresponding SQL query. So if you want to render vector tiles for the entire world until zoom level 14, these are around 350 million tiles. And for in each and all of these tiles, this query runs. So we really need to be focused on making this query very fast. So this should be, you should keep this in mind. And what's also interesting in this query is on the bottom, we can see this term Mapbox. So this limits the data only to the extent of the current vector tile. So we only query this data. And the query is also specific to the zoom level. So the scale denominator defines that, in this example, on zoom level 13, only building with an area greater than 1,700 square meters should show up, and on zoom level 14, all the other buildings. And on zoom level 12 and below, no buildings will appear. So this is how you define what's inside your vector tiles. So you put all these layers there, where to get the data from, and because there's a nicer way to do this than do this by hand, we used Mapbox Studio Classic for this. So you can there easily create a source project, add all these layers, add your SQL query, and on the left-hand side, it graphically shows up what you actually queried. You can hover over the point or the geometric features and see what attributes are there, and it will, when you save it, it will automatically generate this description for you. So now you're ready to create the vector tiles.
So we saw how we do it with the graphical user interface. We can just use this command under the hood. It uses Tilelive all over the place. So with Tilelive copy, we can just say copy this bounding box, the data in this bounding box, from zoom level 0 in this case down to zoom level 14. We use our project we created before and we put it into a destination. And in this case, it is an MB tiles. It could also be S3, or for example, it could be just a file system. And now I will show you how that works in our workflow with Docker Compose. And that's very simple. We just run Docker Compose, export vector tiles, and give it the bounding box, in this case of Zurich. And we will shortly see how it starts rendering these vector tiles. You see, it's Mapnik that does the job, and on the right you see the size. So afterwards, in the data directory, we have our osm.mb tiles with the vector tiles. Because it's just a SQLite database, we can look into it, we can count the tiles, it will be 70, and now we have that file, we can serve it, we can unpack it, we can throw it to S3. We no longer need a complicated server, and that's the power of it. And we already saw other projects, GeoServer, MapServer starts working on this, and there are other FOSS4G guys that are working, like on T-Rex or Tegola, that just turn PostGIS into vector tiles. So you might want to look into those if our workflow doesn't please you. Now, we want to pre-compute the vector tiles for the entire planet so that we can create extracts and everyone can put it on a USB stick or on their mobile phone. And to do that, we cannot use a single machine. So we do our import into the PostGIS database at first. We have our PostGIS database, and then what we do is we just clone the physical bytes, we just clone the disk, and we create clones, like, for example, 16 machines in our data center, and each one of them has their separate PostGIS database. And so we create workers that everyone queries their own database. And this makes it very fast. Otherwise, the database would be the bottleneck if we fire these billions of queries. And now we just divide the entire planet into a grid, divided in 64,000 jobs. Each job is a bounding box you need to render, and the job will take the bounding box, render all tiles within it, store it in a SQLite database, and send it back. And in the end, we just take all these SQLite databases, combine them, and we have a single file with the entire planet. So it's a MapReduce workflow. we just map the job description to the SQLite and reduce it. And so some statistics, if you run it on a single server with 50 gig RAM and only one CPU, this uses 128 days. So you need to scale it horizontally, and we can bring it down to 3 days with 16 machines. So we run 16 machines with 8 cores, actually only 30 gigs of memory. And so if you have money, you can make that as fast as possible. And then you have the entire planet pre-rendered. So serving performance won't be a problem for you anymore. But we already did that for you. So now updates. We can provide real-time updates, but like weekly or daily updates are still possible. And to do that, we just detect the changed features, so what geometry changed. And then we have all these geometries over the planet, and we just find the minimal set of tiles that cover these. And then we just apply this entire process to these tiles. And in the end, we again get a database with just the tiles that changed. And now we can just diff these tiles into our planet from previously, and we have the updated database and can serve it again. And this way, once you have rendered the planet, it's not such a huge investment. You can have a single machine and then can keep OpenStreetMap up to date. And you also see here these patterns, like the boundaries. If an attribute changes in a boundary, all of those tiles that contain that boundary have to be re-rendered. So what can you do with this workflow? If you just want a nice base map, for example, you have a visualization, you want to create a light base map or probably highlight something else, perhaps you can use our tiles. Please check them out. You don't need to do this work of rendering it, spend that money. It's very easy. You can just copy our tiles and serve them yourself. You no longer need us, you're independent. And if you just need like an overlay, you have your 5 features. We have OpenStreetMap, for example, that display marine features like buoys or other things. And then you can just use our Docker template that we prepared here to create a thin vector tile overlay. And you can still combine that with the base map. And that's actually the power of vector tiles, that we can, every one of us can create their own set of vector tiles that we can, in the end, combine. And if you really need something complicated with OSM and you don't like what we did, then you can just fork our project, adapt it, merge your own data, and use that distributed process. And other people are doing this as well.
So yeah, this was basically it. Please check out our website. We really would love to see if you go there. We have tutorials, check everything out. Go on GitHub, have a look at our code, run through the process. If you find issues, we are happy. If you file an issue or hit us up on Twitter. And we hope that we could give you something interesting and get you motivated to work with vector tiles. So we hope that there are getting like more and more open vector tile sets out there, so we can all have fun with vector tiles. Okay, thank you.
Yeah. So thank you for your presentation. Please speak in the microphone, because actually it's supposed to be recorded. So.
Okay. Are the OpenStreetMap source hosted on S3, or are they hosted in a public location that is accessible?
ClockContact provides us with a CDN, so you can access that. But if you don't want to use the CDN, or please download them and just throw them on S3. You have immediate, fast.
Hoping to save that money.
Yeah. It's not that much money. So.
What's the disk space requirement for an entire global coverage?
The entire planet file, the SQLite file, is 54 gigs.
I mean the vector tiles when they've been produced.
54 gigabytes. So it fits on a USB stick, a bigger one.
First of all, I'll have to say I'm sorry, I'm going to ask an inconvenient question.
Oh,
You're probably already guessing which one.
Yeah.
Okay, could you please comment on this current status of the dispute with Mapbox about this like IP claims on cartography? Because I love your project very much, and I'm like a little bit worried if like good guys like you and them are like well struggling a little bit. So.
So, I feared this would come. Please read the issue if you really want to do more. I want to make up your opinion, make your own opinion. We don't think there are legal issues on our side. However, we are just so Mapbox fanboys, as you've seen before, so we want to work together with them, that they are happy. Because without them, it wouldn't even be possible. So we are talking with them to make these problems go away. So you can expect collaboration from us.
I don't see currently any more questions, but please correct me if I'm wrong. So we're doing extremely well on time. So it's still 10 minutes left. So basically, if there are no more questions, I suggest that everybody can get out and have a coffee, because 10 minutes, that's quite a good time. Or you can stay here, however you like. Once again, thank you for your presentation and your insights.